Good morning, professors, and welcome to this new video on the ScienceBus. I am Barbara de Cicco, and in these videos created in collaboration with Wacebo, I will be demonstrating the various experiments that can be conducted using the ScienceBus. Today, we are going to experimentally determine the static friction coefficient that exists between two distinct surfaces. For this particular experiment, which is specifically designed for high school students, we will require the mechanics kit. The experiment effectively demonstrates how the force of sliding friction in nature enables objects to remain stationary, otherwise they would continuously slide without stopping. Static friction is a force that effectively resists, meaning it actively opposes the movement of a body. In fact, we often experience a certain amount of effort when we need to set a stationary object into motion. To effectively move an object, it is necessary to apply a force that surpasses the maximum static frictional force. In mathematical formulas, the static frictional force is represented as negative μs multiplied by n, where the negative sign signifies that the static frictional force is in opposition to the applied force, and more broadly, it is opposite to the motion of the body. Additionally, it is parallel to the plane along which the motion takes place. Mu represents the coefficient of static friction, which is a dimensionless numerical value that signifies the degree of roughness between the surfaces in contact. Conversely, n refers to the normal force acting perpendicular to the surface. In our specific scenario, given that the object remains stationary on the horizontal plane, the normal force will be equivalent to the weight of the object. Consequently, in order to initiate the movement of the wooden cart, it will be necessary to exert a force that surpasses the static frictional force. In this experimental procedure, we shall observe the method to ascertain the coefficient of friction through empirical techniques. Let us commence by acquiring a 5 Newton dynamometer and ensuring it is accurately calibrated to 0. Utilizing this dynamometer, we will proceed to measure the gravitational force exerted on the wooden cart. It will assist us in determining its overall mass. Let us acquire the 1 Newton dynamometer and securely attach it to the wooden cart. Make sure it is accurately calibrated to 0. Then slowly begin to apply a horizontal force parallel to the work surface until we notice the cart starting to move. Let us meticulously document the observed value indicated on the dynamometer, which will correspond to the maximum frictional force encountered. We shall conduct these measurements multiple times to ensure enhanced precision. Let us now proceed to acquire the stackable masses and securely affix 2 individual 10-gram discs to the wooden cart. Let us now proceed to repeat the measurements utilizing the dynamometer, and subsequently we will very gradually apply a force that is parallel to the plane, exerting this force until the cart initiates its movement. Let us record the value shown on the dynamometer and perform the measurements multiple times. The collected data can also be input into an Excel spreadsheet. Now, let us proceed to attach an additional pair of 10-gram discs, thereby doubling the total mass. We consistently repeat the measurements utilizing the dynamometer. Subsequently, we very gradually apply a horizontal force until the cart initiates its movement. We proceed to record the value indicated on the dynamometer. We consistently repeat the measurement multiple times. Ultimately, we incorporate the additional 50-gram mass and proceed to conduct the experiment once more, meticulously noting the newly obtained values displayed on the dynamometer. We will subsequently observe that as the mass increases, the force required to initiate the cart's movement will correspondingly increase. After collecting the essential data, we are now ready to calculate the coefficient of static friction in each scenario, starting with the first 2 masses, each weighing 10 grams. We then continue by adding 2 more discs, each also weighing 10 grams, and finally we conclude by incorporating the additional 50-gram mass. We will notice that the calculated coefficient of static friction remains consistent, as it is solely dependent on the material characteristics of the surfaces in contact and not on the contact area of the object with the surface. Professors, thanks a lot. I look forward to seeing you at the next experiment. Bye.